Hi everyone, I'm Edward Yu. Today we will go through the fascinating world of building pathology and its novel approach to intelligent building maintenance. By the end of this presentation, you will have a comprehensive understanding of building pathology, its principles, repair strategies, and the concept of intelligent building maintenance. Let's start with the definition. According to the AEEBC, building pathology involves the identification, investigation, and diagnosis of defects in existing buildings, along with prognosis and recommendation for remedial actions. It encompasses the entire process from diagnosis to implementation of remediation and evaluation. Think of a building surveyor as similar to a medical doctor. Both professions involve diagnosing issues, whether it's health problems in the case of a doctor or building defects in the case of a building surveyor. Harris' 2001 analogy helped illustrate the importance of accurate diagnosis in both fields. Building diagnosis is akin to studying the causes of symptoms in a building. It is a scientific process that requires hypothesis, testing, and thorough analysis. Without proper diagnosis, we risk applying superficial solutions that fail to address underlying issues. The consequences of a lack of or incorrect diagnosis can be severe. It leads to repeated symptoms, ineffective repairs, and ultimately, the need for total replacement. It is crucial to get the diagnosis right from the start to avoid these pitfalls. Symptoms or visible manifestation of failure provide the initial clues to the cause of a defect. They guide our investigation by suggesting the scope and nature of the problem. Then our assessments involve preliminary site visit, background research, thorough inspection, and comprehensive reporting. We evaluate the severity of defects, their impact, and the cost of remedial work. Diagnosing building defects is complex and requires more than a one-size-fits-all approach. We can't rely on cookbook solutions like we might with medical diagnosis. Each case requires careful consideration of multiple hypotheses and testing to determine the true cause. Consider the alleged causes of leaky homes in New Zealand, for example, with reference to the video on the recent court case decisions I uploaded days before. You can appreciate how difficult it is to determine the real causes of a defect. There are various testing methods for diagnosis, including non-destructive tests, what they call NDTs, or destructive tests, and even extensive opening up. These tests help us differentiate among potential causes and arrive at an accurate diagnosis. Here is an example published by the Department of Building and Housing 2011 titled Weathertightness Guide to the Diagnosis of Leaky Buildings. It suggests 7 steps from pre-site work and visual investigation to different investigation approaches and tests. Then after collecting all these information, a defect analysis shall be conducted and remediation work can then be recommended in the diagnosis report. As illustrated in this James Hardy case report, about the simulation on mold growth risk in the Harditex system, it utilized advanced modeling techniques to predict heat and moisture transport within and through a building envelope and to assess the moisture balance of the system. Another 3 tests on the monolithic claddings reported in the court case report include the Helfand test for assessing water penetration and air infiltration, the RDH test, and a prolonged duration water test. For more details, please refer to paragraph 346 of the report. Building defects can stem from various sources, including design flaws, poor materials or workmanship, lack of maintenance, environmental factors, aging, and vandalism. This is my deterioration theory of building defects. Understanding these causes is essential for effective diagnosis and remediation. Based on this deterioration theory of building defects, we have tested the weathering effect on tile debonding. In this paper, Yu-Ho and Low 2007. This case study explores the effect of weathering on external wall tiling system in a laboratory setting. By investigating the shear strength of the render tile interface, we can better understand the mechanisms of tile debonding due to weathering conditions. And here shows the results of the lab test. The shear strength of the render tile interface decreases by more than 50% after 100 cycles of weathering. It confirms the environmental effect on building defects. Then after diagnosis, the remediation recommendation can range from doing nothing to demolition, but the spectrum of repair strategies can be wide. Sometimes we may strategically downgrade or upgrade it. Each approach is tailored to the specific circumstances and aims to address the root cause of the defect. A good example of remediation strategies can be found at this Department of Building and Housing 2011 publication titled Weathertightness Guide to Remediation Design. The Guide to Remediation Design outlines key principles for addressing weathertightness issues, including deflection, drainage, drying, and durability. 4D. These 4 key principles are essential for effective remediation strategies. The first line of defense is deflection. That is to keep water away. But when water penetrates in, then the second line of defense is drainage and drying. They are to provide means of removing water out and to allow moisture to be removed. Lastly, the materials used must be durable against water and moisture. And the guidance also provides details and examples of remediation for reference. According to Harris 2001, these repair strategies can be classified as abstention, mitigation, reconstitution, circumvention, and acceleration. Abstention means taking no intervention. It simply accepts the defect and let the deterioration trend continues. While mitigation and reconstitution means altering either the environment or the fabric that support the deterioration mechanism or is deteriorating itself in order to reduce the deterioration rate, as shown in these charts. While circumvention means substituting other materials and functions to change the deterioration trend. In contrast, acceleration means speeding up the rate of deterioration. So here shows an example of remediation recommendation for cracks on rooftop waterproofing membrane. It ranges from doing nothing, that is downgrading the performance, to mitigation, such as redirecting source of water, and reconstitution, say by means of re-roofing, or more advanced solution can be a spray of plastic protective layer on the rooftop to circumvent the cracks. Well, more recently, intelligent building maintenance has been developing. In my paper, U 2008, it integrates advanced monitoring system and data analytics to optimize maintenance strategies and prolong the lifespan of buildings. In the paper, it put forward an idea of intelligent building maintenance based on autophagy and immunization concept. That is, the building itself can automatically detect defects and to clear up and prevent similar defects in the future. Here shows an example on how intelligent building maintenance can deal with cracks on rooftop using basilic concrete, which is a self-healing concrete that can heal the cracks by itself. In other words, this new repair strategy can monitor and detect defects continuously and automatically without waiting for inspections. And whenever defects are detected, then they will be cleared up automatically. Another good example of intelligent building maintenance mentioned in our paper is a paint system on wall tiling. Here the photo shows the nerve system installed in a tiling system which monitor the adhesive strength of the wall tiles continuously to detect early signals of tile debonds. It works like our paint signals from the nerve system. Unlike traditional pull-off test, intelligent monitoring provides a continuous, non-destructive assessment of tile adhesion strength. This approach allows for proactive maintenance and early detection of issues. For further exploration of building pathology and maintenance, here are some references for you to read. In closing, let's remember that building maintenance is still evolving, and intelligent approaches like building pathology offer existing opportunities for advancement. By embracing these novel methods, we can ensure the longevity and resilience of our built environment.